Good morning, everyone. How are you all? I hope you all are doing great. In yesterday class, we had studied general introduction of complex number and some question. We have solved some question related to iotha's power. Okay, and we had written a note. The sum of any four consecutive power of iotha's will be always zero. It is clear. Then we had studied what is a complex number and what is purely real and what is purely imaginary and algebra of complex number how when we add two complex number what we our answer and multiply and addition and subtraction. Okay, then the equality of complex number, it is clear. And the next we had studied concept of modulus conjugate, it is clear. So modulus, what is the modulus, what is the value of modulus, it is clear. What modulus is equal to mod of z is equal to root of a square plus b square, where a and b are real number, it is clear. And the second is modulus. Modulus means, sorry, yes, modulus is clear. And the next is conjugate. Conjugate means the mirror image of z with respect to real axis. Okay, mirror image of z with respect to real axis. For example, you have given z is equal to 7 plus 8 iota, and the conjugate of z is equal to 7 minus 8 iota. This is the mirror image of this complex number with respect to real axis. Argument means angle between positive real axis to the line origin to complex plane. It is clear. Suppose that you have given a plane and this is a real axis and this is imaginary axis. It is clear. And this is a point and this is z is equal to a comma b. It is clear. And argument means angle made between positive real axis to the point joined to origin, and this is the point of 0 comma 0. It is clear. And when we join the line this and this is the point in real axis, and this makes a right angle triangle. Okay, it is clear. And this is the length of this positive real axis is a and this is b. It is clear. B. And when we use trigonometric ratio tan theta along this axis, so tan theta is equal to perpendicular upon base. So along this angle perpendicular is b upon a. So theta, tan theta is equal to b upon a, mod of b upon a. It is clear or not? Okay. Then locate the quadrants of z. The complex, how we can locate the complex number in quadrants. Suppose that you have given a quadrant. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. It is clear. In the first quadrant, z lies first quadrant is theta. It is clear. And in second quadrant, z will be pi minus theta, sorry, pi minus theta, and third quadrant theta minus pi, and in fourth quadrant minus theta. It is clear. So when we solve some example, then you can easily understand. For example, you have given z equals to 1 minus root 3. It is clear. In this, when we compare this equation, z is equal to a plus iota b, so we can find out a is equal to 1 and b is equal to minus root 3. When we find out the value of tan theta, so tan theta is equal to root of b upon a. It is clear. So what will be the value of b? Sorry, minus root 3. It is clear. So minus root 3 upon 1. And when we remove the mod, so tan theta is equal to root 3. It is clear. So tan theta is equal to 10 pi by 6, sorry, pi by 3, because in pi by 3 10 gives root 3. It is clear. Then theta is equal to pi by 3. It is clear. It is clear or not? Okay. Then then z is equal to 1 and minus root 3. Then we can find a comma b is equal to 1 comma minus root 3, and this point is lie on the fourth quadrant, because the first quadrant sign is always plus plus, and second quadrant is minus plus, third quadrant is minus minus, and fourth quadrant is plus minus, and this is plus 1 and minus root 3, and this will lie on fourth quadrants. It is clear. And we know very well, in fourth quadrant theta is equal to minus theta. It is clear. So theta will be minus pi by 3, and the argument of this equation will be minus pi by 3. It is clear. We will solve another example. Suppose that we have given z is equal to minus 1 minus iota. It is clear. First of all, we will find out the value of tan theta. We know tan theta is equal to root of b upon a, and is equal to upon, what is the value of b? Minus 1 upon minus 1. It is clear. Then then tan theta will be mod of 1, and which angle tan theta gives 1, so theta will be pi by 4, because the value of tan pi by 4 is 1. Okay, it is clear. Then we will find out the point a comma b. So the value of a comma b is minus 1 and minus 1, and this minus 1, the minus 1 is lie on the third quadrant. It is clear, because in third quadrant tan gives minus minus sign. It is clear. So in third quadrant theta will be theta minus pi. It is clear. So theta will be pi by 4 minus pi. This will be minus 3 pi by 4. So argument of z will be minus 3 pi upon 4. It is clear. I hope you will understand very well. This is a note. Argument of z lie on minus pi by 2 pi by 2. Sorry, argument of z lie on minus pi to pi. It is clear. So some properties of arguments. So argument of z1 plus z2 is equal to argument of z1 plus argument of z2. It is clear. The second is argument of z1 upon z2. Argument of z1 upon z2 is argument of z1 minus argument of z2. Third is argument of z to the power n. This will be n argument of z. It is clear. And the next is argument of z conjugate. Argument of z conjugate will be minus argument z. It is clear. This all properties is similar to log. Okay. I In another example, if z is equal to 1 plus root 3 iota, then find the argument of z to the power 8. It is clear. We will use argument property z to the power n is equal to n argument of z is equal to n argument of z. So in this equation, we need to find out argument of z. We know argument of z. We know argument of z. What will be tan theta is equal to mod of b upon a. In this equation, what will be the value of b? root 3 upon 1. It is clear? So tan theta is equal to root 3. And in which angle theta's value pi by 3? So pi by 3. Pi by 3's angle value is root 3. It is clear? And this A comma B lie on the first quadrant because this sign will be plus plus, positive positive, and in first quadrant positive sign lies. It is clear? So theta's values will be pi upon 3. Theta will be pi upon 3. It is clear or not? So then we solve next an argument of z. An argument of z. What is the value of n? Z to the power 8. When we compare z to the power n is equal to 8. 8 multiply pi by 3 is equal to, what is the value of pi? 180. Multiply 8 upon 3. It is okay. Then this will give some 480. Okay. When we, you cannot see clearly. Okay. This 8 multiply 180 upon 3. When we solve 3 to 18, 3 6 the 18, 60, this will be 480. And 480 angle is greater than 360, then we will subtract this angle of 480 to 360, and this will gives us 120. It is clear? And we change this angle in radian. Okay, when we change degree to radian, we always multiply pi upon 180, and this will gives us 2 pi upon 3, and this is the radian value. It is clear? And the properties of modulus. Okay, so mod of z is equal to conjugate of mod of z is equal to minus mod z is equal to minus conjugate of mod z. All these are equal. It is clear? When we find out the value of mod of z, this will always equal to conjugate of mod of z. And when we find out the value of minus mod of z, this will be always equal to the minus conjugate of minus mod of z. It is clear? For example, you can see if you have given example z is equal to 3 plus 4 iota. When we find out the mod of z is equal to a square plus b square. So this will gives us minus 5. When we solve the conjugate of this z, so z is equal to 3 plus 4 iota. So what will be the conjugate? 3 minus 4 iota. And when we will find out the value of mod of conjugate of z, this will be 5. And this gives us 5 and this gives us 5. It is clear or not? The next property is mod of z1 into mod of z2. So we can separate both complex number mod of z and mod of z2. And mod of z1 upon z2, in division we can separate both numerator and denominator, mod of z1 upon mod of z2. And the next is mod of z to the power n is equal to हम इसमें mod को अंदर लेंगे और n को हम बाहर लगा सकते हैं. It is clear? Now we will solve with another example. Z is equal to 3 plus 4 iota square multiply 1 minus 3 iota upon 1 plus iota to the power 4, and we will find out mod of Z. It is clear? When we use mod in numerator and denominator, it is clear? So mod of 3 plus 4 iota square and just wait, mod of 3 plus 4 iota square into mod of 1 minus 3 iota upon 1 plus iota to the power 4. So what will be the value? Root of 3 square plus 4 square whole to the square plus root of 1 plus root 3 square. It is clear? Upon root of 1 square plus root of 1 square. It is clear. And the next is 9. The value of 3 square is 9 and the value of 4 square is 16. 9 plus 16 into 1 plus root of 3 square will be 3 upon 1 plus 1. It is clear? 2. Then this will be uh, in this equation, uh, root square से रूट कैंसिल हो जाएगा तो 9 plus 16 is 25 and 3 plus 1 root 4 upon root to the power 4. It is clear? So root to the power 4 को how we will solve the root to the power 4? Root to the power 2 whole to the power 2. this से this cancel हो जाएगा तो 2 to the power 2 2 का square 4. It is clear? So this will be 25 upon 2. If you could not understand, I will repeat this question. When we find out the value of mod of z, so we use mod in numerator and denominator. So mod of 3 plus 4 iota square into mod of 1 minus 3 iota upon mod of 1 plus iota to the power 4. Okay, so mod of z is equal to, we know, root of a square plus b square. In this complex number, a is equal to 3 and b is equal to 4. So 3 square plus 4 square. 3 square is 9 plus 4 square is 16. Whole to the square into 1 square 1 plus root 3 the square upon denominator में 1 square plus 1 square to the power 4. रूट से आपका स्क्वायर रूट कैंसिल हो जाएगा तो 16 plus 9 is will be 25 and root 3 square is 3 3 plus 1 4 root 4 upon root to the power 4. It is clear? And this will be 25 upon 2. Some miscellaneous property. Okay, so this is very important property. So z dot conjugate z, this will be always mod of z square. Okay, second is conjugate of z. In this, with the help of this equation, uh, conjugate of z is root of z square upon z. It is clear? And the third is um, mod of z1 plus z2 whole square. Okay, so we know mod of z square will be z dot z conjugate. So z is z1 plus z2 and this conjugate will be z plus z2 का conjugate. It is clear? And we separate the property z1 plus z2 dot z1 conjugate plus z2 conjugate. Then we will multiply z1 z1 conjugate plus z1 z2 conjugate plus z2 z1 conjugate plus z2 z2 conjugate. It is clear? And z1 plus z2 mod of z1 plus z2 whole square will be z1 dot z1 conjugate will be z1 square. For this property, with the help of this property, z1 dot z2 z2 square, z2 z1 and z2 z1. It is clear? The value of z1 plus z2 square mod of this will be this. So if you have any confusion, if you want to ask some question related to this topic, and if you could not understand any question, you can ask me in comment section. And thank you so much.